Aga meil tuleb maa üks versioon. Kell 19.10 tuleb maa üks versioon ja pärast seda tulevad esinemised. Nii ütles mulle korraldaja. Nii öelda mulle Playtechi HR. See
siis teevad maja tuuri ja...
Jah, ma sain nii aru, mul nii öelda. Ja pärast seda teie töötate siin või?
Ma töötan ja ma esinen ka. Ma olen esimene esineja, nii et...
Playtech on teile oma särgi kinkinud.
Ja ma pole pannud mingit asja, et ma esinen, nii et...
Selle võib ikka peale panna. Et see pange särgi vaadelt läbi.
Niimoodi, jah?
Teeme väikse soonki. See pange vöö peale.
to get started? Yes, we are. So, hi everyone. Good to see you at our 54th, I guess, DEVCLUB event. And big thanks to Playtech for kindly hosting this one. And for today's agenda, we have two talks. One is by Playtech's very own Dmitri Dorofejev, Java team lead, and he will be giving an introduction to Google protocol buffers and how do you use the technology for designing cross-platform protocols. And second talk is by Move Guide's Joonathan Mägi, technical lead, who will be a bit more on the outside with Kubernetes and Istio. And between the talks, we will be also having, well, Playtech will be also having an office tour. So anyone who feels like the office tour, please keep that in mind. And you can find Katrin to attend the office tour. Katrin, say hi. All right then, I'm passing the mic to Dmitri. Please welcome him on stage.
Thank you. Hello everyone. Welcome to Playtech. Welcome to DEVCLUB here. So let me introduce myself. My name is Dmitri Dorofejev, and I'm the Java team lead in the Playtech live games server platform. So what we're going to be talking about today is the cross-platform protocol design with Google protocol buffers. So a few questions just to break the ice. Any Java developers here? Good, good. Has anyone used protocol buffers before? Okay, so small handful of hands. So I think it will be interesting in the whole presentation. So just a small introduction, the protocol design complexity can be compared with the complexity of designing good APIs, because you have to take into account business message size, performance, sustainability. So any decisions, or good or bad at this point, will impact your future development and the communication with the clients. So first of all, small presentation how we use protocol buffers at Playtech. So first of all, we're using protocol buffers to communicate with our clients. We have Flash clients, HTML5, mobile. With Flash clients, we're using binary version of the protobuf. With our HTML5 clients, we're exchanging JSON over the WebSocket. So when messages reach our cluster, they will connect or be routed to one of the services, and internally we also use protocol buffers inside our cluster for the entire communication. And on the right hand side here, our deal applications, which are not publicly available, again interface with our platform using protocol buffers in a binary form. What is good about protocol buffers is the size. Message size is small and therefore very performant. So now let's go on to a small introduction to actual protocol buffers themselves. I'm not going to be talking about version 2 of the protocol buffers, because not that long ago Google released version 3, which is a lot better. It has some better abstractions, data structures. So keeping that in mind, today's presentation will focus on version 3. So what are protocol buffers? First, this short sentence describes it. It's a framework to serialize and deserialize structured data. So what this means is that you can write sort of a pseudocode, which is language neutral, platform neutral, and then it can be compiled to any target language. So let's say if you want your protocol buffers to work in Java, you take that pseudocode, you compile it, and the result are Java classes. Same goes for other languages like C#, C++, JSON. So this is the biggest advantage. And of course, because of the small size, protocol buffers are good for different industries where performance is critical, like financial, gaming, IoT, and industrial systems. So how does the protocol buff actually works? First, developer will write their definition of different messages in a file with the proto definition. There's not that many text editors available, but in IntelliJ you can download the plugin, which will do all the syntax highlighting for you and also shows if there's any errors or you missed some important keyword. So that will be a big help. So next step, once that's done, depending on how your project is built or how your project is organized, let's say if it's a Maven project using one of the available plugins, either ProtoStuff or ProtoC, the proto files can be compiled into a target language. I will show later in a demo and examples session how it's done. And let's say if you're having your proto files in a separate repository and you're working locally with them, you've written your proto files, you compiled, Java classes are readily available. And also what you get as a benefit of those classes, they're very structured. So you're going to have builder pattern implemented, they will be immutable, and also having some helper methods to check whether some values are set or not set. Right now you want the ProtoC compiler is the default given to us by Google, but it's not very convenient to use. The ProtoStuff framework, which is maintained partly by actually colleagues in our team, is I would say more convenient to use. It has Maven plugin. Contents of the files can be extended. Like if you want some specific code in your Java files, then you can write templates for the ProtoStuff for Maven, and your Java classes will have the necessary methods. So here I'm gonna try and show most of the data structures and keywords or some other options that the protobuf gives to you. So first line, as you can see, it says syntax proto3. This is really important because from now on, our compiler will know that we're working with a protobuf 3 and not protobuf 2. The keyword option, it's a command to a compiler. So let's say you can, when the compiler builds your classes, it can put them into a specific package. If you, let's say, you hold your proto files in a package called Playtech game proto, then the resulting classes can be put into a completely separate package. Each of the proto files can be imported from each other. So let's say if you have some common abstractions like enums or message types, then you can reuse them in other proto files just by using an import statement and including the proto file. Some of the examples here will come from our background here, so I tried to make them as generic as possible. We start with message, with word message, and then we put the name of the message itself. Then you can define different fields. So string corresponds to string in Java, int64 it's a long, int32 is long. You can use comments, so either single line comments or multi-line comments. very interesting feature is the one-off. So what one-off gives to you is that the serializer and the serializer will always expect one of the payloads. So in our case, in our games, we have different types of clients and we have players playing different tables. So we always expect one of the payloads to reach our server, so whether it's blackjack, roulette, baccarat, or some others. Also very important, the numbers you see after the equal sign, these are so-called tag numbers. They're used when the protobuf messages are put into binary form and they go to wire. The tag numbers are used to order the content of the message. So what you see here, the actual message batch response, that doesn't get serialized. What will get serialized is the actual content of the message. And the order of the tags defines the order of how those fields will actually go into basically in your connection channel with the clients. Some more abstractions here. The multi-line comment looks very similar to a Java language. The keyword repeated, it's an alternative to list. So repeated keyword here will end up being a list in Java classes. In 32 and the deprecated true. What this means is that it tells the users of the protocol that this field is deprecated. This is another feature of the protobuf, that let's say if you stopped using a field, or you're saying for clients do not use it anymore, then you mark it as deprecated. So in your Java classes, this will end up being with the deprecated annotation. So here I'm just defining the messages that were in the one-off section. The keyword reserved. Sometimes it may be necessary, or you want to delete a message, but you don't want anyone putting non-compatible types in there. So you just mark it as reserved, you put the tag number, and then no one else will be able to use it. Like let's say server developers, they want to put a new message type and you reuse tag 50, you basically prevent them from reusing this tag, so that old clients will not break in production. Booleans, so we can define Boolean fields. They are always false by default, but you can put the default value as true. Enums, very simple language to write enums. You just use enum keyword, name, and the list of enums. It's considered a very good practice to add a default enum, which will be with the tag 0, so that in your code you can always check. Sometimes you can use unknown here. So let's say a client sends to you an enum which you don't recognize, you can fall back to unknown. Or if it's not set, then it will also be unknown. And the last thing I wanted to show is the map. So again, often used and very useful feature. You can define maps in protobuf. Important comment, since the classes are immutable, it will return an unmodifiable map. So if any of the developers tries to modify this map, they will get an exception. Next, protobuf not only supports messages or Java classes, it also supports definition of services. So let's say if you have one microservice implementing service 1, service 2, another microservice with service 3, 4, and 5, and so on. You can also describe the services in the protobuf syntax, and it will get compiled into Java interfaces. So the keyword here is RPC, so the services will be RPC style, which means they will return a future. They are non-blocking. I just think it would make sense to use blocking services here, because that just would block your clients from receiving the response. So here we have a request type and response type. That's it. I've left them empty, just for sake of brevity. So also what this saves from you is from writing boilerplate code for your services. You just get interface and return types for free. Small introduction, what actually happens after you've written the proto file, compiled your Java classes, how they actually get transferred to your target destination. Essentially, a message is just a series of key value pairs. So if you take your string name tag number, this will end up on a binary form where the tag and the length of the message will be at the beginning and the message content after that, and so on. So the messages are strictly ordered in the order of tag numbers. The very important sentence is the last one. The name and declared type for each field can only be determined on the decoding end by referencing the message type definition. As I said earlier, the messages themselves, they're not transferred over the wire. So you somehow have to provide the deserializing part with the message type. So either you need to wrap your messages into a wrapper code, or you just add another field into your message with the type name. Tags are unique identifiers. You cannot have tags with the same index. The message just won't compile. Another interesting feature, default values are never sent over the wire. So let's say if the sending side will not set an enum or integer along, that doesn't get serialized, but the deserializer will still return you default values when you request them. And another important aspect, protobuf messages are not designed to handle large messages than 1 megabyte. I would like to see anyone writing a protobuf message larger than 1 megabyte. It would be huge. So for this, you need to use streaming. So an example how it looks like in binary form. The example are pretty simple, but give an idea. So here we have message test with the int a with tag 1. So when we give a value of 100, this will be the binary representation. Tag number is converted to 08, and then the value goes next. For strings, it's a bit more complicated. For strings, the serializer also adds a length. So in case of integers, the tag number acts as key, and in case of strings, the tag number and length will act as key for the serializer. A few drawbacks of the protocol buffers. First of all, you cannot do inheritance. Why is this important to understand? It's at the design stage, so that you know that you cannot extend any classes, so that you have to use nested classes to add all the information. And of course, messages cannot be too big. Otherwise, serialization and deserialization will just take too long and your performance will suffer. Any questions so far? Am I going too fast? Or the pace is okay?
Yeah, I have a question about type safety.
Yes.
So, what happens if I describe a message? Can I specify that this field is required? Some specific.
That's required?
Yes.
In Proto 3, no. There's no such word anymore. The Proto 2 used to have a keyword called required, but that was a big, I would say, negative side, because it's basically forced you to always send this message to your clients and never remove it again. So there is no special keywords in front of your field. It's just type and field name. And it's up to the contract with the clients whether clients expect this message or not. You have to collaborate with client developers a lot, or with users of your protocol.
But the clients that actually get generated, pretty much everything is optional in this?
Yes.
Arch. Okay.
Not pretty much, but everything.
Everything is optional, but it's important to talk to the users of the protocol. You have to consult them. This is all going to talk on my next slide. So you have to consult them, tell in which case the message will be sent and in which case it will not be sent. Yes.
Can I specify the string encoding when I send the string, or some default encoding is used always?
There is a default encoding in protobuf. is using variant encoding. So if you just say string, then that's all you can say.
Okay, so it's UTF or how does it know?
How does it know? I guess for this you have to go into protobuf code itself and read a bit more, because I haven't actually checked on this topic. Yes. Okay, so cross-platform protocol design. I've outlined some of the general principles. So I would say one of the very important ones is make sure team understands how protobuf is working, because that is crucial. Of course, all the protobuf changes would pass review by client developers, server developers, but it's still important to understand what is happening when you write the message and what will happen when the message will go into wire. Because sometimes you can change types. So let's say scalar types are compatible, string types are compatible, but you need to understand what you're doing. So protobuf documentation, how it gets compiled, very important to know. Next, communication between server developers and client developers. Again, server developers shouldn't be writing protobuf files on their own, unless it's inside the actual platform. So as soon as the protocol goes out, it needs to be consulted with the other developers, because this is pseudocode and everyone understands it. Follow consistent naming pattern. I'm gonna give a few examples where it's actually bad examples. Let's say if you use word get in some places and then you start using obtain, that's confusing, don't do it. Or let's say add and include, or success and successful. So try to use short names and consistently, otherwise there'll be confusion, misunderstanding, people just will forget the purpose of the messages or fields. Message and field names must be self-descriptive and single purpose. I think the best example of the message or a field name is that when it doesn't require a comment in the protobuf file. Of course, a comment may say why this message was added, but there shouldn't be any comment saying what this message actually is. Otherwise, the name is wrong, you have to change it. Clear comments and change log. So whenever you work in a protobuf, or on the protocol, always write comments why something was added and the changelog file, because this is going to help other developers to see what you did, why you did it, and also will help client developers as well, because client developers to the target platform. And every component in the ecosystem must be aware of its current protocol version. So server needs to know its protocol version. Clients need to know that. Any other applications reusing your protocol files, they need to know the protocol version, because they need to update it and to receive the latest updates. And let's say if client communicates to the server, then they need to send the protocol version, because the server will act accordingly. Yes?
Does it mean that if you want to bump the protocol version, you need to bump it everywhere at once?
Not necessarily. Changes to protobuf are backward compatible.
Okay.
It's a no-no to break backward compatibility. The important factor is that server has to be newer than the client.
Okay.
Because server will always support some new fields in the protocol, clients will still use the old fields, everything works. If for some reason, new client, old server, there will be an exception at some point. This is more like a general principle, but still applies to protocol design. Keep clients simple by sending all necessary information from a server. Don't let clients do any weird calculations, anything. Whatever client needs, send it. Create clear abstractions for messages that need responses and for messages that don't need responses. So, as a rule, all the messages, requests will need response, even if it's empty. But there may be situations when, let's say server needs to push something to the client and doesn't need a response from the client, because networks are unreliable, you don't know, maybe the message didn't arrive. In this case, create a separate abstraction and call it notification, for example, then you know that whatever message is called notification, that will not require a response. So I already mentioned networks are not reliable, especially mobile networks. So from this unreliability comes the next point, it's idempotency of the messages. Quite often, even in our example, when the player plays at the table, player gets disconnected. So if player sends us some request, we need to be able to handle it in a way that we understand that the player just continues his table session and that's not some new message. So idempotency is something that needs to be considered. So the best practices here, you add some generated ID by the client, which server can check, so that you don't depend on the actual other content of the message. Automation. Automate protocol build and release processes. Do not do this manually, because again, you will run out into different weird situations. So whenever change is done in protocol repository, create a release version that can be already used by the clients. So the good practice here is whenever something gets merged into protocol repository, it becomes a new release and can be used by the clients straight away. So in this case, master is always a stable branch with the stable changes. Second. When the team started using protobuf, it was just taken as a good alternative to previous implementation of the protocol. So that's the reason why the team started using it. Because the previous protocol was text-based, so it was a string protocol. And now this is binary, so it's a big step forward. And it, I would say, powers the whole the whole live games right now.
Joonathan was first, then.
So my question is whether you have or are internally using protobuf in different languages other than Java as well. And the second question, whether you have looked at gRPC or anything similar.
So the question was, you said do we use it for anything than Java?
Yes, between different languages.
Okay, so in our server now, we only have our server platform is entirely written in Java. Yes, our dealer application, they compile it to C#. Our Flash clients compile it to ActionScript, and our HTML5 clients compile it to JSON. Yes, so they all have access to the raw protofiles, and they build it into the target language. And I think I didn't answer the
gRPC question, whether you have looked at that.
No, we haven't. Although the protobuf natively, I think, supported.
So the guy on the back.
Is the JSON format?
No, sorry, not you. You're the next.
So, how big of the gains did users see when you migrated from text-based performance to that binary-based?
I would say the biggest gain was for developers themselves. The protocol became a lot more structured, easier to maintain, and less prone to errors. And we were able to discuss protocol changes with Flash developers, iOS developers, HTML5 developers, whoever. They saw the pseudocode, they understood the purpose of the change. They proposed some like enhancements of what we wrote. Maybe said no, it's wrong, do it the other way. Then we discussed it. So this was the biggest benefit.
And there was another question.
Is the JSON format using the actual field names or the numbers as keys?
Actually, and field names.
And since the binary format is targeted towards small packet size, is protobuf doing its own compression?
No, it's not doing compression. It's not that required because the messages will be small anyway. What I did mention is that you need to keep in mind if you have very size-sensitive systems, then let's say any tag numbers from 1 to 15 will take 2 bytes to encode. then any tags from that number will take more bytes to encode, but the messages are very, very small.
Last question, please.
Am I right in thinking that the versioning thing is for smaller changes? If you need to make a bigger change, then you could define a completely new message type.
Or it's better to define a message.
If you make a bigger change,
So you don't end up with a loss of legacy fields.
yes, very much depends on the change you're doing. I can give an example. If we develop a new game, let's say some sort of poker game, and of course we'll create a whole set of new messages. And where needed, in places where we need to include these messages, we include them, but it will be basically the whole set of new messages. Yes.
Okay. That's it for the first talk. Thank you so much.
Thank you.
Thank you, guys. This is a small present from the Dev Club. Thank you for doing this talk. So
Thank you.
everyone, let's have a break, 15 to 20 minutes. Grab a beer, have a snack, join the office tour, and let's meet here in 15 to 20 minutes again. Thank you.
Office tour is there.
Guys, yes, office tour. If somebody wants to raise your hand, how many of you? Okay, can you gather?
Yeah, we said we let it go, but we settled for the last. Couldn't let you want it though. Who am I to let you down? No.
Клиентам и внутри как таковых углов и нет. У нас есть, например, балансировщик, он знает, куда посылать сообщения. Вот. И он также знает, какие сервисы как бы на каких хостах работают. И вот он знает, что, например, там сервис, который принимает такие документы, обрабатывается там, вот, например, одним из этих трех серверов. И он туда сообщение посылает, там оно принимается, десериализуется и уже вызывается нужный метод. То есть такая примерно система.
Ну понятно, спасибо.
Üks esimene osa ongi, et lähed nagu oma inimeste juurde ei leia seda artikleid või tähendab.
See projekti, kus vaadatakse peale, küsitakse, mis framework'i sobiks siis sellised asja, et me oleme Java-lused ja kõik Javas.
Javas oli tal olemas. Just mingi puut ja läks.
No, mõni projekti üks asi, mida saab teha väga palju on see S-tähega framework.
Framework.
Saad sa panna?
Mis on hästi lightweight framework. See on siis ma vahepeal, see oli selline hästi lightweight.
Mida iganes.
See on mingi lightweight asi, mida ma eelistan selle jaoks, sest ongi, et see on lightweight, et omal rock kontrolli juurde.
Sul ongi see, sa vastavalt sellele vaatad. Sa suudad selle skoobi ära ei ole seda framework'ist vaja.
Et see ongi, nad umbes, nad ei taha teha sellise asja, kui võtavad framework'i kaasa 10%. Nad üks asja teha ja seal ongi, et
ma arvan, et praegu on iga asja jaoks raamistik olemas, on väiksemaid raamistik on suuremad. Ma olen päris nullist ise kirjutada küll, mitte midagi nüüd. Mina nagu sellega ei nõustu,
see tasub ära.
Ma ei tea, kuidas teil see ära tasub, mina just näen igas projektis on kõige suurem probleem see, kes seda maintainib. Kas sa viitsid oma seda, mis iganes. Sa räägid, et 10% kasutad, aga mõtle, kui see osa, mis sa ise kirjutad, on seda suurt raamistikku kasutades. See osa, mida sa ise kirjutad, on võib-olla 5 või 2%, mis sa muidu kulutaksid selle kirjutamiseks. Kõige olulisem on ikkagi see aeg, mida sa ise kulutad. Jah, ta ei ole võib-olla nii optimaalne. Mõnes case'is sa ei saa seda kompromissi teha, aga enamuste veebirakenduste puhul sa saad. Valid selle võib-olla kõige parema versiooni nendest valikutest, aga jah, on natuke suurem library, ma ei kasuta sealt võib-olla 50% või 70% sellest ei kasuta.
Mulle ka see mõtleme nagu, ma kasutasin ka sama mõtlemist, et kui ma ennast springiga lähen, kui mul kuul teas kohe springis, siis ma tulen initsiatiivselt nagu tundub asjad esimene teha. See ongi, et seal keegi küsib, et see oleks keelt sa teed. Et see läheb projekti ja siis sa vaatad, okei, siin kasutaks need rubid, siis kirjutas rubid. Aga okei, siin on sees, kirjutas teed, et siis jumala.
Ei, seda küll, ma kujutaks ette, et muidugi asja viitsiks isegi on õigem nullist kirjutada nagu absurdne. Ma arvan, see aeg on möödas, kui ma viitsin mingi raamistigi kirjutada, see kooli aega. Enam ma ei viitsi.
Ma ei tea, mulle peale üks ametlik hästi ja ka nagu.
Ei, mitte üks, ma ei räägi sellest, ma ei räägi ühest, aga lihtsalt ma katsetan ka hästi palju erinevaid uusi asju. Tänu sellele suudadki selle otsuse teha, et mis asi on selle projekti jaoks õige. Lihtsalt minu jaoks ei oleks kunagi õige nagu null või from scratch ei oleks nagu minu jaoks kunagi option. Puhtalt oma laiskuse pärast, ma arvan. Kui see just mingi Hello World ei ole. Isegi Hello World ei viitsiks teha enam mingi raamistikku.
Nad ongi seal teinud kindlasti sealt kirjutasid Yeti serveri peale, kus sa lähed hästi staffima.
Mis toimub?
Nagu vaid sa nagu lihtsam.
Mis asi on lihtsam?
Kontrollivad kõike ja see on natuke, nad kontrollivad kõike ja nad ei ole selle pärast räägida.
Ma ei tea, mul oli tuttav sellest olukorrast ja ettekujutus, ma räägin talle, mis seal toimub, siis too jääks kahe käega peas kinni.
Ei, see on, nende numbrid näitavad, et see töötab.
No see töötab sellepärast, et kliendid ei vaata võib-olla koodi. Kas teil ei ole seal siis, kus teil, ma ei tea, info nagu suurem või sellised pangaprojektid on, et see kindlasti selliste hangete puhul tehakse mingi tehniline analüüs sellele resultile nende poolt ka, on tarne.
Jah, need vahekliendid jah testivad asju. Siiamaani ei ole keegi tarne.
Niimoodi kirjutate, ütleme, kui see ise oma asja nullist kirjutate, kirjutate testid kõik või selle jaoks.
Jah, testid kirjutas mingi, see ikka läheb.
Kõik on testitud.
Kõik, see kood.
Kõik, jah.
See kood on alati testitud. ja see ongi niimoodi, et kliendile öeldakse, et selle jaoks, et see kood testada
maksab nii palju rohkem ja kui siis klient ütleb testimist ei ole vaja.
No me ütleme, et mis...
Töötab ka võib-olla ilma.
Jah, et see on et mõnes projektis klient otsustab selle ära, et see ongi see projekt sellised kuidas meie seda teeme, et sul ongi mingi 20 mega mälu selles kipi peale ja kirjutasin ja siis selle, et seda asjad teha niimoodi, et saaks testi teha, siis on tõesti, et läheb 3 kuud nagu veel otsa,
ei oleks setitav olnud liiga kaua, jah.
Aga sükesed Java projekti, need on lihtsalt testida, seal me ei küsi, ei kasuta arvaspraktikas, samamoodi Java sõita arvaspraktikas. Aga Eesti kohvana kindlasti mõtlen kõige parem jätkab isegi nagu öeldud kultuur on nii võrd. See ongi esineda, mis sul maas sellest maailma.
Ei, ma kujutan ette, et arendajale küll jah, kui ma ei tea, tahaks nagu best practice'id jälgida, siis võib-olla mitte.
Ma ei vaata.
Nad sunnivad peale oma practice'id.
Nad on ikka, ma ütlen, et nad on kindlasti best practice on nende olemas. Ja just kas see efekt, et sa teed paarist, et see nagu suunab sellele, et programmeerimine ei ole koodi kirjutamine, vaid sa mõtled kõigepealt ja siis sa lihtsalt ja 2 pead mõtlema. Et see suunab palju rohkem sellele, et on nagu mõtlema. Et see, ma ütlen, et minu arust peaks tõesti kõik programmeerimine vaadata. Et see ei ole lihtsalt koodi printsiip, et sa mõtled ja kõigepealt.
Ma ei tea, meil on kuidagi selline, et võib-olla selline algusaeg võib-olla on selline koolitamine ja paaris progemine ja mingi hetk läheb ikka sellest raamist välja.
Ja siis sa lähed koodi topma ja siis sa lähed nagu teha see mõttetöö efekt kaoks ära.
Ei, aga see mõttetöö tehakse analüüsi faasis võib-olla ära juba.
Teil on mingi analüüsi seda?
Ei, veel ei ole, võib-olla vastu tulevad. Aga meil on pigem see, et tehakse selline probleemi analüüsimine eelfaasis ära ja lõpus, kui see nagu arendustaskini jõuab, lõpliku lahenduseni jõuab, siis nagu ei ole pigem koos implementatsioon siis.
Näiteks ma just 2 päeva lahendid seda, et meil on nii vähe mälu ja siis võtab palju mälu, eks ole. Ja kuidas seda teha, et meil on mingisugune päev aega või rohkem tegime, siis muutime ära ühe numbri, eks ole. Järgmine päev, kes on 3 numbri. Et seal on ikka kogu aeg analüüsi kohustusest appi, et seda üksinda saada sellest, et projektid on nüüd täna minu arust väga raske.
Üks asi, mis mulle väga ei meeldi, on see erinevate projektide vahel switchimine, see on ka oled ühe asja juba selgeks saanud, siis tuleb mingi järgmine asi. Aha, okei, väga huvitav. Keegi on siin mingi hunniku valmis kirjutanud. Ma ei tea sellest mitte midagi, kõik küsivad mu käest. Mis toimub? Miks ei tööta? Miks see nii kirjutatud on? Ma ei tea, mina ei committinud. Dokumentatsioon, kus on? Ei ole.
No see ongi, et mina läksin uude projekti, mul oli kohe paariline ja kohe läks, aga sai kohe kaasa rääkida. Et meil oli pigem see, et kui sa uus ise võib-olla lastaks sul natukene üksinda teha, et sa esimene nädal oled paariline, järgmine nädal saad 1-2 päeva üksinda vaadata projekti ja siis juba lähed uuesti paariline.
Meil on lihtsalt väga palju kontoris ringi jooksmist ja üksteise käest küsimist.
Minu jaoks on see meeskonna efekt tekkis täpselt seal, et see, et sul tuleb paari, see on nagu
meeskonna efekt ikka siis, kui sul on lihtsalt mingi väike tiim ja mõne ütleme mingi viiene tiim näiteks tekib ju tegelikult. Teile antakse mingi ühine teenus või ühine projekt.
See võimaldab tegelikult sul ikka tekkida üks arendaja, kes istub üksin nurgas, kui mitte üksinda koodi. Meil tükast asja ei ole üldse.
Ei saa ju, meil üks kuidas võimalik on selleks, et kui sa sellest kas teil on mingi stand-up'id või Scrum meetingud?
Iga päev on komplivaid.
See ei ole võimalik, see protsess ise ei võimalda sul tekkida, siis on mingid sellised arendajad, kes sul nurgas istuvad ja üldse ei räägi midagi.
No ta ütleb tund ma ei taha.
No selline arendaja ei pea väga kaua vastu selles ettevõttes, ma arvan. Katse lõpuks teada, kuule, et see vend väga ei sobi meie kollektiivi.
See just ka Mägi lihtsalt on kogu aeg seal partnerid olemas ja üks oli vähest neerega.
Touch me soft. dreams unfold. Let it come around and let it breathe over me. It's time to go away into the light. I feel the calming energy. I see the darkness coming, and I'm calling you to help me set me free. I'm calling for you. I'm calling for you. I'm calling for you. Lie all the fate of the world in your plans, guarding your faith with the palm of your hands. I know, yeah, I know. It's the unknown, the unknown. It's time to go away into the light. I feel the calming energy. I see the darkness coming, and I'm calling you to help me set me free. I'm calling for you. I'm calling for you. I'm calling for you. This is the end of Cyber this record. Please
Yeah.
We gathered a bit of information we ask you to fill in some forms about like where do you work and what programming languages do you use, etc., like we always do. And we took a look at this data, and regarding in terms of your favorite programming languages, Java is of course, well, why of course, but Java is still an absolute winner this time. Who writes Java on a daily basis? Please raise your hands. Okay, keep your hands up who enjoys it. All right. Good for you, guys. Seems like not much work for you there, Jochen. Everybody seems to be happy with their jobs. Okay, then.
Do you have any alternative options?
Yes.
Any alternative options to Java?
Python is also pretty big.
It's because of the students.
Might be, yeah, indeed. Or the data guys.
What's the sample size?
Excuse me?
What's the sample size?
The sample size is like 74, I guess, like the total amount of tickets issued. So the not listed is basically the languages that were not in the list. And other is all the languages other combined, including Golang and Ruby and whatever was their JavaScript. So that's it from my side. I'm passing the mic to Joonathan Mägi, who will introduce Kubernetes and Istio. And please welcome him with warm applause.
So hello all, I'm Joonathan Mägi from Move Guides, where we are building a global mobility platform to easily move people from one place to another. And today I'm going to talk to you about Kubernetes and Istio. And I hope by the end of the talk you're not afraid of any of these. You have better understanding what they can actually provide you. Ways to run with both of them. Istio builds on Envoy proxy from Lyft that has seen quite a bit of usage, and most of the Istio components actually are production ready. But of course you should test Istio for your own use cases. Kubernetes is currently in version 1.8, but Istio is like 0.12, so that kind of might tell you something as well. Istio especially, and then Kubernetes as well, they're not built for microservices. You can actually build your monolith applications, and you still gain quite a lot from both of these. And Istio is definitely just complementary to Kubernetes. So if you don't want Istio, don't use it. Get started with Kubernetes. Get the easier deploys. Get the insight that Kubernetes will provide you out of the box. And if you see that something is still missing, take a look at Istio as well and what it can provide you. A few words about what the hell the Kubernetes is itself. So Kubernetes is end-to-end system to automate your containerized application workflows. So that means that it helps you automate deployments. It takes care of scaling. It can do auto-scaling for you, whatever you might need with containerized applications. That includes observability, getting logs out from the containers, and it can do it on all the possible cloud platforms on your bare metal, so it's perfectly well portable. You can use it on your laptop, you can use it on your own personal server somewhere in your closet, or host it on AWS or Google Cloud or whatnot. Kubernetes got started at Google, where they have seen scale of Google scale. So they knew what they started. By now it's donated to the Cloud Native Computing Foundation, and then they're governing the project. And as it's taking care of containers, it actually supports by today multitude of different container platforms. But of course the most popular one is Docker. So that's what we might be taking a closer look today as well. Now if we talk about building blocks of Kubernetes, then the most core one that drives everything in Kubernetes is pods. And then pods are for running one or more containers in a shared storage and network space. If you're running multiple containers in a single pod, they are of course co-hosted, and they share a context. Then we have replication controllers. Replication controllers take care of actually keeping these containers running. So when you schedule the pods, you define in your replication controller how many of these pods you need running, and the replication controller then takes care of monitoring those. So if any of those dies, a new one will be provisioned, and so on. So in most of the cases, you have containers running, you need a way to access these as well. And for that, Kubernetes is providing service abstraction. And service abstraction is a logical set of pods and as such containers as well that are targeted using the label selectors. So here, for example, we can see that requests come into the product page. Product page itself is a service running pods. Then of course this is a fine example of microservices with multiple levels of requests going in and out. It might be hitting review service, and review service itself might to target those pods hosting those containers based on those labels. And of course, actually to get access to your services from the internet, or Ingress actually can be used within your cluster itself as well. Kubernetes has defined Ingress, and Ingress is something that can actually take care of just load balancing. It can take off SSL termination, and all of these components are actually composable. And then, for example, Ingress, you can use different Ingress providers. So if you're running on AWS, for example, your Ingress can be ALB based. If you're running on Google Cloud, it's Google Load Balancer. Out of the box, actually, Nginx is, for example, supported as well, and so on. So many different building blocks are not on this page, but these are the main ones. And if you know these, then you can actually already get started, and you know how your application would be running on Kubernetes clusters. So what are the best ways to actually run Kubernetes? So I've split this slide into 3 different sections. First one, of course, if you just want to get started with development on Kubernetes platform locally, today the easiest way for that is that you just go to Minikube page and then get started with Minikube on your local laptop. The default way of running Minikube is using VirtualBox, but of course there are different ways to do that. If you're on Windows, you can use Hyper-V underneath and whatnot. Since the beginning of next year, hopefully you can get started with Kubernetes already from the Docker for Mac or Docker from Windows straight away. And currently you can go to beta.docker.com and then sign up to receive the announcement when they are ready to provide that platform to you. If you are looking to get started with Kubernetes, but you don't necessarily want to manage your own clusters, because it definitely brings some overhead, then currently the 2 best ways for that are Google Kubernetes Engine, that was previously known as Container Engine, and Azure Container Service. And here the Google version of this managed service actually is definitely production ready. Azure Container Service has been available for some time, but they are still in a beta phase. So
if you want to get free credits, get started, both of these are actually great ways to get started with Kubernetes as well. You don't have to worry about provisioning the clusters. You don't have to worry about managing the etcd, worry about some state there and so on. And if you just want to build your own clusters, know what's actually happening underneath, maybe you have some special security requirements that you can't get checked off on any of the hosted services, then for AWS currently the Kubernetes operations KOPS is the best way, and for anything else kubeadmin is a fine way to get started. And today we'll actually be looking at KOPS because probably still here in Estonia, AWS is the main cloud provider for many of us. And KOPS is the de facto way to provision Kubernetes on AWS. It provides fully automated installation. That installation can be self-healing, or actually self-healing it is definitely, because everything will be provisioned in auto-scaling groups on the AWS. It can be highly available. It doesn't necessarily have to be, but here in Kubernetes context, highly available actually means that the master is highly available. All your nodes are running on containers are running on nodes that are split up into multiple machines anyway. So you can run multiple master nodes, and then KOPS has support for this. And KOPS will actually start supporting probably Google Cloud, or actually in some way or form it already does support Google Cloud. They are starting to support VMware and then other different platforms as well. So it's actually interesting competition, because both like KOPS and kubeadmin are official Kubernetes projects, but they're kind of competing with one another as well. So sorry for this if you're not on Mac, but this is how easy it is to get KOPS and AWS CLI tools that are necessary to follow along on your Mac. So I'm just using Brew here, Kubernetes CLI. So that's actually providing the kubectl Kubernetes CLI tool that you can use to perform actions on the clusters. Then there's the KOPS tool itself, and AWS tools as well. So as you can see from this, the KOPS tool actually runs on your own laptop and uses your laptop to start provisioning the cluster. It doesn't have to be your laptop, of course. You can use it on some Bastion host on your machine, on your data center or whatnot. And all these installation instructions actually are available for all the other platforms. So you can as easily get started on Windows and Linux as well, of course. There are some prerequisites to get started with using KOPS. Depending on what's your security policies, if they are very loose security policies, or you're just getting started and want to play around, then you can go with as much success, or even use the AWS root account if you're willing. But these are the permissions that in a simplified form, what the KOPS utility needs to actually start building your clusters. For my demonstration, I actually have an account with all these necessary permissions already provisioned. So the next step to get started is that we need preferably a bucket or some place to store the KOPS state. So we are creating the bucket here, and I actually have created the bucket already myself as well. And we are naming our cluster, and then we are pointing the KOPS to a state store. Actually, these are user creation, so it was a lot of talk before, but this is how we actually can get started. Kubernetes KOPS supports different topologies for creating your cluster. So we might go with private topology, so all your nodes and the masters are not actually publicly on the internet. They are in private subnets. COPS supports different networking ways of networking as well. You could go with Gallico, Wave, whatnot. You can provision a Bastion host as you go as well, so it actually sets up a proper environment for yourself. So there's a Bastion host that you can use to SSH into some of the nodes if you need to do some debugging and so on. And before coming to the stage, I actually ran this command here in a little bit different form because I was using different network provider, but it is quite verbose and it's probably not very well perceived on a large screen, but I just ran it here before so we wouldn't spend like 5 minutes. That's how long the cluster takes to come up. And the command that I actually ran was this. So I created a cluster. I used EU Central, so that's the Frankfurt AWS region. I provisioned 4 nodes and then 3 masters. So masters, like 3 is the, if you want to do highly available kube cluster, then the 3 is the lowest master count that you can go with due to the etcd. I of course used private topology. I used the simplest Copeo networking using VXLAN. The Bastion host was of course provisioned, and I set the name, cluster name, and then the state here on a command line. The create, actually what it does, it creates the configuration. So actually to provision the cluster, we updated with minus yes, and then it actually went on and applied all the changes. One interesting fact here is that you don't necessarily have to use COPS to actually apply all these rules or create the cluster. You can actually ask COPS to provide you with the Terraform formulas to provision the clusters yourself. So yeah, instead of spending some time waiting, I actually pre-provisioned the cluster. And then we can actually take a look whether the cluster came up, because I didn't test that. So hopefully everything actually worked. And hopefully there's internet. So it seems that everything actually worked, and we're running the 1.7.10 version. That's the latest officially supported by COPS. You can go with the beta stream and then get 1.8 as well. COPS can actually validate the cluster for you as well. And here it does some additional checks whether the cluster is ready for you or not. And you can see that there's like what are the instance sizes, and everything is listed there. And then we can take a look whether the Kubernetes components that are actually providing to Kubernetes, because Kubernetes pretty much self-hosts, so Kubernetes schedulers and everything themselves run on Kubernetes as well. And then we can see that everything seems to be fine here as well. Everything seems to be running. So that was getting started with Kubernetes. We have a working Kubernetes cluster, and then we can start thinking about and Istio, and then what the Istio is, because I think Kubernetes many of you might have heard before, but Istio might not be so well known. So Istio is something that people call service mesh. What it actually means is that it just helps your services to connect to each other. It provides traffic management, so you can do additional things that Kubernetes itself, based on its own labels, can't do. It can provide observability in addition to Kubernetes observability, so you can actually understand service dependencies. You can start drawing service dependency graphs using Istio. It can provide policy enforcement. So say you are hosting services by many different teams on a single cluster, and you don't necessarily want other teams using your services. You can actually build Istio rules that deny some of that traffic, or you can rate limit them or whatnot. And it's all done based on policies that require no code changes on the application side. And then same actually goes for the traffic management and observability. And Kubernetes and Istio actually takes care of providing service identity and security as well. So if you're running your services and you want to be sure that the other service talking to your service is who it says it is, Istio can provide mutual TLS between these services, and Istio acts as a CA, so certificate authority, providing these identities to you. And Istio is built on top of Envoy proxy, and Envoy proxy has been started at Lyft, and it has seen quite a lot of traffic recently, especially in the Kubernetes community, where other things other than Istio are being built on top of Envoy as well. So we saw that getting started with Kubernetes was relatively easy. Then actually installing Istio is even faster. What you actually really need to do is just get the latest Istio zip file, unzip it, and deploy it using the default Kubernetes kubectl apply command. Istio YAML is the definition that defines all the different services that need to be provisioned for that. So let's take a look how that actually would look like. So these are all the different resources and the metrics and everything that Istio defines for itself. And this was actually deploying Istio. Now, the containers right now are booting up, and we can see what are the services that that Istio defined. What are the building blocks for Istio? So here we can see that there's Istio egress. So all the traffic going out from the Istio cluster will be routed through that. There's Istio ingress. So that's the traffic into your cluster being load balanced. We see Istio Mixer. Istio Mixer is a service handling collection of metrics and policy abstractions and stuff like that. And then the Istio Pilot is the control plane for the whole Istio project. So that gets your policies and then executes necessary actions on those. And then we can see whether everything is actually running. So yes, we can see that services have been up and running for almost a minute already. So that was how easy it is to get started with Istio. But to actually get some cool functionalities of Istio out of the box, we can deploy some Istio plugins as well. So let's get started with deploying, for example, Istio Prometheus plugin. So this actually installs Prometheus into your cluster and then also already starts gathering metrics into Prometheus. We can install Grafana plugin. So if you like pretty graphs, you probably know Grafana. This just provisions, deploys Grafana, and then there's already some predefined graphs in there for you as well to get started. As I promised there, you can get started with getting your service graphs out from the cluster as well. There's a plugin for that. And you might have heard about distributed tracing, all the hype. If you're running microservices, you want to understand what's talking to what and how long those requests are taking. So here we installed the Zipkin and then the Jaeger agent, the Uber's version of Zipkin, or also supporting the open tracing. So all of those now have been deployed as well. So these are the slides that we have already covered. So we installed quite a lot of stuff by just running few lines in your terminal, and all of these services have been provisioned. So previously, if you have tried to install like Grafanas and Prometheus and everything, that might have taken quite a bit more time, but these things here come out of the box.
Question.
Sure.
Do you come with the Istio installation?
So Istio provides baseline of it all, but these are plugins, but yes, they are part of Istio. So these the YAML files that I executed, the Kubernetes YAML files, are actually within the Istio distribution.
Okay.
How is it different from Docker Compose?
I let some Docker experts answer that. It's better. It's slightly different. Kubernetes allows you more control over some of the things. I think they try to like Docker Compose is getting closer and closer to Kubernetes as well with what it's doing. So, but the Docker is now a great friend of Kubernetes. So all the Docker clusters in the end will start supporting Kubernetes. So I don't know what's the future story with all the swarms and everything is. So far we have prepared our cluster and we have Istio. Istio is ready to go. It's trying to do something, but we have no real application running. So let's easily deploy an application as well, and we will be deploying the same application that I showed you before. So it's an application that actually has multiple tiers. So it's a book product. It pretty much provides product pages for books, reviews, book details, and ratings as well. And then we're covering many different languages here. So Python, Java, Ruby, Node. So something for everyone here, I hope. And getting that deployed, as we saw before with other things, is relatively easy. But here's a small trick for that I'm using for Istio. I'm using the Istio CTL to kube inject some stuff into the deployment files as well. So you can actually automate this and make it totally transparent. I haven't done it here because it's easier to show you what's actually happening. But the kube inject actually, when we now go back to the slide and then try to remember how this slide looked before, we can see, and then I told you that one pod can actually include multiple containers, and what has happened here is that all the pods have been injected with the out from your different applications goes through the Envoy proxy, and this allows Istio to do a lot of things without actually applying any code changes. So this allows to gather all the metrics, provide all the observability features without you actually needing to do any code changes. And here I'm promising you a URL, but actually to make it work, I'm gonna do a small hack as well. Hopefully it works. But meanwhile, until it DNS magic happens, we can take a look at what are the services that now have been defined. So we can see that there's the product page service running, rating service, review service, and detail service running. Let's see how many pods do we have. So we can see that there are multiple different versions of review application. We have a rating application, and we have product page and then details. They have been up for 2 minutes now. They are running. They don't have restarts. Restarts means that if one of the containers there, for example, fails, it gets restarted by as the Kubernetes keeps things running. And hopefully So hopefully the service actually itself is up and running as well. It is. And then one interesting thing that you can see here is that the review section is actually changing as I refresh. And this is why because I have 3 different versions of the service running. One the application label that the service is targeted on is the same, but actually they are different versions. So we are actually, as we refresh, we're round robin hitting different service versions. So this is probably not how you should be running your services in production. Oh, like you might gather some information. This you can call this A/B testing, but probably you want a little more control over this. So ideally, let's try to use Istio to route all the traffic to the version 1 for now. And then we're going to use Istio CTL to actually apply some rules. And now if we go to the page and we continue to refresh, you see that there's no change. So we are now always hitting the version 1. So this was all done without any code changes. I didn't cheat here. I didn't redeploy the application. I just applied some policies. One simple use case that you of course might think of is like, before I roll out my next big version, I might want to test it. And how do I assign some test users to actually get the different version of the page or something like that? So Istio has a potential way of helping you for that as well. And to show you that I'm not actually cheating, I'm gonna log in. I'm gonna log in using my name and a very safe password. So here you can see that my user currently is seeing the version 1 as well. So there's no star ratings there, nothing fancy. And let's say that we have developed the new version of the reviews application. It's already deployed as well, as we before saw. But I want the user Joonathan to actually test that. I applied some rules again without code changes, as the code changes were already deployed. My user is now always hitting the version 3 of the application here. If I log out, everyone else still are hitting the version 1. So we have a simple capability of testing using the test user our functionality capabilities. And then let's take a quick look and how that actually works, or what the rules look like as well, because there are of course many ways of doing that. And always you can't just use a name and a cookie as we do here, but let's take a look. So here we are taking a look at the request headers, and we are looking at the cookie, and my super safe login mechanism just sets my name into a cookie, and then here I'm able to look that the user cookie contains the value Joonathan, and here I'm routing it to label version 3. And potentially you can use this to some sort of a test rollouts. You don't necessarily have to use a username there, but you can set some sort of a test group test group cookie or anything like that, and then this might already solve some testing use cases for you. What else cool could we do? So we got test user running. Maybe we want to start gradually rolling this out. So it seemed that it was working for the test user. Let's get some percentage of users on it as well. Again, we can easily do that with rules and policies. By applying a policy, actually 50% of the available capacity should be hitting the different version. So if we continue, and you can like access it publicly, it's publicly available, books.kubernetesexample.co.uk/product page. You can actually go to the application and refresh and try it out. And then finally, if still all our metrics and everything looks okay, we can just actually roll all the users over to the version 3. By running simple policies, and we can clean up the Joonathan test user policy as well. So here we have actually completed the test cycle and safely rolled our application into a new version by testing multiple versions in parallel. So this is that something that Istio just provides out of the box. Of course, this is just part of the functionality. Before I promised that we can get, using the plugins, we can actually do some relatively cool things as well. So as we saw some usage on it, hopefully there are already some cool graphs that we could show you as well. And the graphs, of course, would be live. So I locally, as the cluster is a private cluster, and I don't want to build some VPNs or anything fancy into the cluster, I'm actually using the Kubernetes capability of port forwarding cluster ports into my local machine. And here, let's take a look if we can get to Grafana. So this is the auto-generated Istio dashboard with some service mesh information. We can see HTTP traffic, services traffic already here as well. We can see per service traffic, and then the information like traffic going into different versions, latencies, whatnot. So this all comes out of the box. And as Istio supports TCP services as well, gRPC, whatnot, as you start using some of the functionalities, more and more of these graphs will be auto-generated for you as metrics are discovered by Prometheus. And then this is all live, currently proxied from the Cube cluster to my machine. So I promised you something else as well. I promised you service graphs. Again, we're gonna port forward one of the Istio plugins locally. I have the tabs open here. So this is how the service graph for this book application looks like. Request coming in, hitting Istio ingress, going to product page, and then we can see the traffic diverging into different versions of the review applications. We can see how many requests per second have been there, and then some of these services actually are hitting the rating service as well. So this is something tiny that comes out of the box, but actually it might already be useful for you if you have Istio running. Again, for this, we didn't do any code changes to the application. And last but not least, here we're gonna take a look at some distributed tracing as well. Distributed tracing is especially useful if you really are using microservices and you want to understand what's going on here. So we're using the Jaeger interface. Let's see if there are any traces. And as we deployed the Istio plugin before we started doing anything with the application, it actually has continuously been gathering traces from the application. And then we can take a look at the product page traces, and then we can see which services it has been hitting, what the latencies have been there, and so on. So again, out of the box available, And of course, if you want to extend here, and if you're doing any database queries or anything like that, some of that stuff Istio can actually gather from the sidecar proxy as well. But if you're doing anything other fancy stuff, you can actually make your application report additional information to using the open tracing protocol as well. So this is all extendable. So you don't necessarily have to live with what the Istio provides out of the box. So it's all meant to be extendable. So these are the different things that that we have currently covered. And we didn't touch any of the security features. Other stuff that Istio can do for you, like retrying automatically the requests that fail, for example. So it can do stuff that you usually would implement in your code. Some of that stuff can come free for you, like circuit breakers, for example. If there's enough failures, it can break the circuits. Automatic retries, mutual TLS to authenticate, and so on. So if you want to get more information on this, then of course Kubernetes.io and Istio.io are perfect resources, and both have quite good documentation for everything. You can get the same book application demo. It's part of the Istio distribution, so you can get started with different policies there. Change the policies, play around. It has more coverage for all the different functionalities. It's really easy to get started. And if you still want to continue with microservices and stuff, then of course move guides would have use for you as well. So we would be happy to talk to you. And with that, I thank you. So these are Kubernetes and Istio, and then hopefully you can find some use cases, and you can go back in the slides and then get easily started with this. Be it your microservices that you're building, or just if you have some legacy services running and you want to understand what your legacy services are doing, just deploy Istio into your code otherwise. Thank you.
That was hell of a demo. Thank you so much. We got a couple of minutes to answer some questions, so if you have any questions, it's the right time. Kirill? Okay.
I'll probably ask this question. We all saw that it's quite easy to roll this thing out. And it seems that there's a layer on top of another layer and some add-ons and plugins.
Yes.
Have you run into some issues which were like not because of you but because of the underlying system, and how hard was it to troubleshoot?
Troubleshooting is relatively easy, and I think part of that actually is thanks to it being layer on top of layer, because you can troubleshoot a specific component throughout the different. It's usually on a single layer, and then you can get logs, instrumentation, everything from that layer, and you know where that actually is coming from. Of course, there will be problems if you especially with Istio, you can find some edge cases where it doesn't probably support your use case, and so on, because as I said, it's still 0.12 as its version. Everything that has to do with the Envoy sidecar and getting the information out, the metrics, and using the traffic policies, I haven't seen any real issues with that. Kubernetes has been solid. Where some issues can reside there are like a different, again, a separate layer taking care of the ingress, for example. There can be some edge cases there because it's providing ingress is rendered differently in the different environments. So in AWS it can be ALB, ELB, there can be some issues there. The portability on the definition level is there, but maybe not the functional support on ELB or ALB is not on par with what, for example, Google Load Balancer would be able to provide you. So some of that stuff you need to work around. Debugging is really easy. Both of these actually have very healthy communities that are really easy to take part of as well. And if you're running on one of the hosted providers, then that actually takes part of that management out from your hands as well. That can be good and bad. For example, if you want to do the Istio automated injection without using the Istio CTL to kube inject, then by default on the stable version of Google Cloud that wouldn't be possible. If you're running on the, you can boot up your cluster in the alpha mode, and there it's possible. So they take some of the control away, but getting started, I think in a managed way is definitely the good way to get started. And then you understand whether you want to build some of the plugins yourself that you wouldn't be able to run unless you self-host and so on.
Right, synchronous way of stuff, but there are people living in asynchronous world. What they have to do with that?
Kubernetes supports all sorts of use cases. Like there are jobs that can run totally in the background. Kubernetes supports cron jobs as such with scheduling.
I'm not talking about the Kubernetes. I'm talking about Istio.
Istio is still for mostly for like the RESTful or gRPC or like a type of interface where there's some in and out traffic that you want to monitor from end to end. But if you're doing some async stuff, then for example the distributed tracing would still work. Like if your async call is doing calls underneath it, those would still be captured and so on. So you still get all that information for free. If you're hitting your asynchronous service somehow to get it processing something, you can still route that with Istio capabilities. So most of that stuff is still very useful.
This is not my area, so sorry if it's too basic question, but about Kubernetes. It was a few years ago a Google, like I understand, internal project. It was even presented at DEVCLUB. And what has happened since then? What is this CNCF? Who manages it and what is the community around it?
So CNCF is the Cloud Native Computing Foundation. They now have many projects, other projects that you might know. For example, RethinkDB, for example, is something that's underneath them, and then by now quite like a ton of projects. I think Docker has given Containerd over to the CNCF and stuff like that. So it's a really healthy community. A lot of supporters. I can't know by heart who else like are supporting there, but community is truly very, very active. And I think 2 years ago Kubernetes probably was version 1.2 or something like that. Ton of things have definitely changed. A lot of new capabilities, not necessarily many that we discussed here today, but for example, all these asynchronous stuff happening on Kubernetes or cron jobs, for example, and things like that are all new capabilities. Ingress as such is a new concept. It was previously, like accessing your cluster was previously defined differently and so on.
And the last question. So, how is support for stateful services?
You just use stateful sets in your set. Stateful is becoming a thing on Kubernetes. So if you're first, of course, you can use volumes and then volume claims to actually mount stuff where you store the state, and then these move along with the pod wherever it's created. It still mounts the correct volume, and then there the backing services, of course, are provided by different cloud providers. And if you're self-hosting, then you have to take care of some of that yourself. And if any of your services need stable identity, then stateful sets actually help you there. So if you're running multiple replicas that need to connect to each other, that wouldn't be possible with just connecting using the service name as such, then stateful set actually provides a use case that's useful there. So it's getting there. I think it's safer if you get started without considering state, and then if you can get by using some hosted service to manage your state, then I think you will be much happier. But if you need to care about state, then Kubernetes has a story for that, and there's a lot of information on Kubernetes.io on that as well.
Thank you so much, Joonathan.
That's a great talk.
Yay.
Nice to see you from us.
Thank you.
So, thank you guys. It was really awesome one, and thanks so much to Playtech for kindly hosting this event. See you on December 19. We booked the place. We don't know yet what will be going on there, but